So good day everyone. My name is Jeremiah T. Abisha and I am the fourth reporter of Group 1. And my topic is all about sieve analysis of aggregates. So sieve analysis of aggregates. Sieve analysis is also known as gradation test. It is a laboratory test procedures that is an effective way of analyzing or determining the particle size distribution of coarse aggregates within a given sample. Is the process also separates fine particles from coarser particles by passing the material through a number of sieves of different mesh sizes. So particle size distribution is defined using the mass and volume. Particle size determination on large samples of aggregate are necessary to ensure that aggregates perform as intended for the specified use. Particle size distribution can affect a wide range of properties such as the strength of concrete, solubility of a mixture, surface area of properties, and even their taste. So sieves also is a wire screen having square openings. It is a size of these openings gives the sieves their name, which is called sieve number. A sieve with a mesh opening of 4.75 mm is designated as 4.75 mm sieve. So there are two methods in sieving analysis. The first one is manual sieving method and the second one is mechanical sieving method. So the first one is manual sieving method. It is carried out in places where there is no electricity and mainly used in on-site differentiation among large and small particles. In mechanical sieving method, it is used in laboratories to assure the quality, and this is the widely used method in present days. So there are two groups in mechanical sieving method. The first one is the horizontal movement sieving method. It is a sieving method that utilizes purely horizontal mechanical movements. The other one is vertical movement sieving method. It is a vertical movement sieving method is also known as the throw action sieving and vibratory sieving methods. So there are two ways in weighing the material retained on each sieves. The first one is the dry sieve analysis. It is considered mostly in here the testing particles are in dry state. Another one is the wet sieve analysis. It is carried out after the dry sieve analysis. The purpose of the wet sieve analysis is to remove all the particles which are finer than 75 microns particles from the sample so that we arrive at a correct sieve analysis result. In performing sieve test, one must consider and know the two categories of coarse grained soil. The portion of soil which contains particles size bigger than 4.75 mm is retained on the sieve. This portion is called gravel fraction. Gravels having grain size is greater than 4.75 mm. The portion of soil which contains particle size less than 4.75 pass through the sieve. This portion is called sand fraction. It is also called having grain size smaller than 4.75 mm. For gravel fraction, we require sieves of sizes 80 mm, 40 mm, 20 mm, 10 mm, and 4.75 mm. This set is called set of coarse sieves, as it sieves coarser part of the coarse soils. Second set of sieves for sand fraction consists of sieves of sizes 2 mm, 1 mm, 600 micron, 425 micron, 212 micron, 150 micron, and 75 micron. If we didn't mention, then 1 millimeter, that is millimeter, is equal to 1000 micrometer, which we denote as letter micron. So 1 millimeter is equal to 1000 micron. So here, 600 micron is actually 0.6 millimeter. This set of sieves is called set of fine sieves, as it sieves finer part of the coarse soils. Part of the testing is weighing the material. So there are two methods on weighing the sample. First is the cumulative method, where each sieve fraction, beginning with the coarsest, is placed in a previously tiered pan and weighed. This process is repeated until all fraction and the bottom pan have been added and weighed. This is a good time-saving option since you don't have empty out or tear the pan on the scale. In cumulative method, as each retained fraction is added, divide the cumulative mass by the total mass of the sample and multiply by 100 to calculate percent retained. Then subtract the cumulative percent retained on a given sieve from 100 to calculate percent passing. The second one is the fractional method, where operator weighs the contents of each sieve fraction separately, waiting to discard material until the entire test is complete. The technician also calculates the amount retained and the passing of the sieve to the nearest 0.% by the total mass. On the other hand, fractional method is divide the mass retained on each sieve by the total and multiply by 100 to calculate percent retained, and then calculate percent passing by subtracting the percent retained on the sieve listed beneath. For calculation purposes and to determine some important characteristics, we also calculate two values. The first one is cumulative percentage retained. Now, cumulative percentage retained of any sieves is percentage weight retained on that sieve plus all percentage weight retained on all the sieves above it. Second value we calculate is percentage finer, using which we plot a graph called particle size distribution curve. Percentage finer is, as name suggests, is the percentage amount of soil which is finer than a particular sieve. And here are all the formulas on how to get the cumulative percentage and percentage finer. Here are also the testing tips. The first one is avoid overloading sieves. Allow enough time on a sieve shaker or testing screen for a complete separation. Watch for degradation. Consider reducing shaker time intervals or using a different method. Check sieves for wear, torn mesh, or distorted openings regularly. Do not use tools or probes to dislodge trap particles. Take care when transferring material to the tare weighing pan. Don't forget to pre-dry the sample. So, determination of unit weight of aggregates. There are two standard test methods in determination for unit mass, the loose method and the roded method. The procedures using loose method: determine the weight of the empty bucket, fill the bucket overflowing by means of shovel or scoop, exercise care to prevent segregation of the particle size of the sample, level the surface of the aggregate using straight edge, clean the outside of the bucket and remove excess dust and particles, Determine the mass of the bucket with aggregates and record the data. So for procedures using rodded method, fill the bucket one-third full. Rod the layer of aggregate with 25 strokes of tamping rod evenly distributed over the surface. Fill the bucket two-thirds full again and rod 25 times. Fill the bucket to overflowing and rod again for 25 times. After rodding, level the surface with a straight edge. Clean the surface of the bucket and remove excess materials. Determine the weight of the bucket with aggregates and record data. After using either of the two methods, unit weights are then calculated with the formula as follows. The formula is W over V. Thank you and God bless.